Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad HAKIM. This is PBL assignment for electronic communication system. So I will introduce our group member. So our group is consists of 6 group member, and our group number is group number 1. So the first group member is ADILAH, MAIZAN, BINTI, ZULKHAIRI, and the matric number is 190075. And the second group member CHING, and the matric number is CE200003. And our third group member HAARISH, anak lelaki LETCHUMANAN, and the matric number is CE200171. And this is me, Muhammad HAKIM bin NADZRUDDIN. My matric number is DE190136. And the group member number 5 is LIYANA SHAFIQAH binti SHUKOR, and the matric number is DE190047. And our last group member is AGILAN, anak lelaki RAMESH, and the matric number is CE200096.
Hi, Assalamualaikum. My name is LIYANA SHAFIQAH binti ABDUL and my matric number DE190047. Okay, I would like to explain you about the convert the limitation from amplifier to unitless and chamber to Kelvin and convert the GAN from dB to unitless, temperature from degree. Okay, for this answer, I will be explain to you about how to convert the GAN dB to unitless and temperature from degree to Celsius. Okay, for this GAN, we use this formula GAN dB equal to 10 log F, which is that we get the result for chamber 1 is 6, and for chamber 2 is 40, and chamber 3 is 10. Okay, for the temperature, which is we need to the result, which is we use Celsius, but to convert the Kelvin, we need to plus the 273 Kelvin, which is for chamber 1 we get to 350, and chamber 2 360, and chamber 3 450. Okay, that's our result for this PBL activity 1. Okay, thank you.
Hi, I'm ADILAH MAIZAN with ZULKHAIRI. So I'm going to explain I'm going to show the steps to calculate the noise power for each chamber and input. So before we proceed with finding the highest value of SNR, we need to find the noise power for each chamber and the input. So for the input noise power, it's equal to KTB, which is K is the constant value, 1.38 times 10 to the power of negative 23 times with the temperature. So the temperature that we have converted into the Kelvin, and the bandwidth. The bandwidth is 500 megahertz, which is given in the instruction. So this is the value for input noise power. Next, for the noise power for chamber 1. So K times with the temperature for chamber 1, which is 350 Kelvin, times with 500 megahertz. And the value is 2.415 picowatt. And then for the noise power for chamber 2, K times with the temperature in Kelvin, 360 Kelvin, and 500 megahertz. So this is the value for the chamber 2 noise power. And the last chamber is 1.38 times 10 to the power negative 23 times with the 450 Kelvin, the temperature, and also the bandwidth, 500 megahertz. So the last chamber will be 3.105 picowatt for the noise power. And then we can proceed to find the highest value of SNR.
Selamat sejahtera Doctor, my name is BEJ30103 and my battery number is CE200003. Okay, I'm going to continue the presentation on how to calculate the SNR value for this problem. Okay, theoretically, we know that the formula for calculate SNR is APSI over APNI plus ND. AP is the gain of the amplifier, SI is the power signal of the input, and then NI is the noise power of the input, and ND is the internal noise. In this case, we contain of 3 chamber and 3 amplifier. So I've made some modifications at the formula. Okay, and finally I got this formula, SNR equal to SI G2 G3 G1 divided by NI G2 G3 G1 plus NI G3 G1 and N2 plus N2 G1 plus N3. Okay, the NI is going to be the noise power for the input, N1 is the first amplifier, the noise power for first amplifier, and N2 is the noise power for second amplifier, and N3 for the third amplifier. The next step is we just need to insert the value into the formula, and we got the value of SNR is equals to 2.7361 tera. And then we need to convert the output into decibel. And finally we got 124.37 decibel. Okay. In order to obtain the highest value of SNR, we must arrange the amplifier from the highest gain to the lowest gain. If you don't believe this, you can try to change the arrangement of this amplifier to compare whether the final SNR value for each calculation that we obtain. You will obtain the SNR with the arrangement that have the highest value of gain will be bigger. Okay, that's all for me. Thank you.
Greetings, Doctor. My name is HAARISH Kumar, son of LETCHUMANAN, and my matrix number ECE 200171. And I'm from Group 1, and now I'm going to explain about the question 2 and its answer. Okay, let's see the question 2 first. This question 2 asks about, without considering the mentioned conditions and limitations, what could you propose to further enhance the output SNR, which means to improve the output SNR? The answer is, as per our observation, the other method to enhance the output of SNR is by reducing the temperature. The noise produced from thermal agitation is directly proportional to the temperature, which means corresponding to the temperature. It also mathematically derived as noise temperature equals to noise power over Boltzmann constant times with bandwidth. Okay. Moreover, as the temperature is reduced, the value of noise power will be reduced. This is because when the noise power is reduced, the SNR obtained will be increased. The highest the SNR value that we obtain, the better quality of the communication system is. This is because the unwanted noise or signal can be reduced. As we can see, this is the formulas of SNR, which means signal power over noise power. Okay, that's all from me. Thank you very much.
Hi doctor, my name is AGILAN. I'm from Group 1, ECS, Electronic Communication System. This is our fishbone diagram. First, research and data collection. We get the data from journal articles, group discussion, recall theoretical knowledge. Our group problems, how to design a communication system with the maximum SNR output. What formula related to the question. Observations are, as the temperature is decrease, the value of the noise power N will also decrease. Temperatures will be in Kelvin to be used in finding noise power. This is our group formula to find SNR, total gain noise power, and SNR dB. Next, this is our group self-reflection. The first question is, what is the new knowledge you have learned from this assignment? The new knowledge that we have obtained from this assignment is to analyze many types of electrical noise and digital modulation technique in communication system. Furthermore, we have observed the fine value noise for each chamber and arrange amplifier to obtain the higher value of SNR. Second question, in your opinion, what is the most complex issue in completing the given task? The most complex problem is given task is to find the most effective way to ensure the output of SNR and best solution for SNR based on the given parameters. How did your group comes with the idea of the best possible solution to the given complex problem? We came up with the best solution with help of tutorial knowledge that we gained during ECS class. Moreover, we also had a deep research in internet, read multiple journals related to the topic of the assignment. That's all from our group. Thank you, doctor.